We've learned that a functional group is an atom or a group of atoms present in a molecule, which determines the characteristic properties of the molecule. For example, methanol, ethanol, and propanol all contain the hydroxyl functional group. All these compounds react with sodium metal and liberate hydrogen. Thus, we can conclude that organic compounds that have similar functional groups show similar chemical reactions. Functional groups play an important role in determining the properties of a compound and are used to organize organic compounds in different classes. Based on the structure of the compounds, they have been organized into classes and assigned IUPAC group prefix and suffix. The alkane group suffix is ane, A-N-E. The alkene group suffix is ene. The alkyne group suffix is ine. The halide group prefix is halo. The alcohol group prefix is hydroxy and the group suffix is -ol. The aldehyde group prefix is formyl or oxo and the group suffix is -al. The ketone group prefix is oxo and the group suffix is -one. The nitrile group prefix is cyano and the suffix is nitrile. The ether group prefix is alkoxy. The carboxylic acid group prefix is carboxy and the suffix is oic acid. The carboxylate ion group suffix is -ate. The ester group prefix is alkoxycarbonyl and the suffix is -ate. The acyl halide group prefix is halocarbonyl and the suffix is oil halide. The amine group prefix is amino and the suffix is amine. The amide group prefix is carbamoyl and the suffix is amide. And the nitro group prefix is nitro. The sulfonic acid's prefix is sulfo and the group suffix is sulfonic acid. Now let's see how we can use the prefix and suffix to assign names to compounds. Step 1. Identify the functional group in the compound. In this example, the functional group OH belongs to the class alcohol. As per the IUPAC system, the suffix for the alcohol group is OL. Step 2. Number the longest chain. If we number the chain from right to left, then the OH group is on second position. And if we number the carbon chain from left to right, then the OH group is on fourth position. As per the naming convention, functional group should be attached to the carbon atom with the lowest possible number. Hence, case 1 is the correct way of numbering. Step 3. Assign a root word. As there are 5 carbon atoms in the chain, the root word will be pent. Step 4. Assign a primary suffix. The chain only contains single bonds. Hence, the primary suffix will be ane. Step 5. Assign a secondary suffix. The functional group is OH, that is alcohol. Hence, the secondary suffix will be ol, OL. Step 6. Specify the position of the functional group. the functional group OH is present at the second position. Hence, the position of the functional group will be 2. Thus, the name of the compound is pentan-2-ol. But some compounds have more than one functional group. These are known as polyfunctional compounds. In such compounds, one of the functional groups is chosen as the principal functional group. The principal functional group is selected based on the order of decreasing priority as shown here. Carboxylic acid has the highest priority, followed by sulfonic acid. Esters, alkyl halides, amides, nitriles, aldehydes, ketones, alcohols, amines, alkenes, and alkynes. In the given compound, carboxylic acid will be the principal functional group, as it has higher priority than the ketone functional group. The name of the compound is written on the basis of the principal functional group. For this, we need to start numbering the carbon chain from the end nearer to the carbon atom to which the principal functional group is attached. The principal functional group will come as a suffix. For carboxylic acid, the suffix oic acid is used. The other functional groups act as substituents, and they are written by using appropriate prefixes. Here, the substituent is ketone, and the prefix used for ketone is oxo. Thus, the name of the compound is 5-oxohexanoic acid. If the same functional group appears more than once in a compound, we name the compound by adding di, tri, etc. before the suffix, and the full name of parent alkane is written before the suffix. In this case, since 2 carbons are present, therefore the word root is eth. A single bond is present, therefore the prefix is ane. Hence, the name of the compound is ethane 1,2-diol. Now let's name this compound. In this compound, there are 2 functional groups attached, nitrile group and alcohol group. As the nitrile group has higher priority than alcohol group, we will number the carbon chain such that the carbon of nitrile group gets position 1. Hence, the name of the compound will be 3-hydroxy-4-methyl-pent 4-ene-1-nitrile. The terminal E of the parent chain is retained as it is followed by a consonant and not by a vowel or Y. On the other hand, in the next compound shown here, there is a double bond and a triple bond. In IUPAC nomenclature of organic compounds, a double bond gets preference over a triple bond. Hence, the name of the compound will be pent 3-ine 1-ene.